Hello, good afternoon. Okay, let's get started. Yeah, if you have any question regarding to the lab 1, please let me know. We still have 20 hours to do the submission. So for the lab 1, basically you just need to submit a PDF file. So just follow these steps to the submission. So use this command to compress the file into a TAR file. Then you run the command to do the submission. Yeah, if you don't know how to do this, you can also use the RAR. Like you can use your own computer to do the compression, it's okay. But make sure you can open it in the VLab. So once you have done the compression, just put it into your desktop and then try to open it. Make sure we can open it. Otherwise, you will get 0 marks. Do you need to submit all the supporting screenshot as well? Actually, no, because if we mention in the exercise says include all the output into a report, then you need to do. But if we doesn't mention, you don't need to put like extra pictures into your submissions. I think it's okay to submit while the web page. Okay, so just follow the steps, then you'll be fine. Yeah, and that's it. And one extra thing is you need to make sure the picture in your report is clear. So try to open it in the VLab because sometimes we cannot see the pictures. It's not clear. So make sure your picture in your PDF is pretty clear so we can see. And let's do the exercise 2 because we don't have much people for today. I reckon maybe need to wait for 5 more minutes. So we start from the exercise 1. So exercise 1 and 2 should not be included in your report. But let's do it anyway. So this week we have learned how to use the HTTP, right? The HTTP protocol. So in exercise 1, we are trying to communicate with a web server by using this stuff. We call it telnet. So let's just follow the steps. Run the terminal and copy and paste. You can see we have connected to this website while the port number 80, which is the HTTP. And then we should send the command get. So in here, I just try to copy this one and type it here. So we send this information, this one, this information, and then we get a response here. It's a bad request. So as you can see here, this one is, this part is basically a HTML file. So if you copy the content and save it as a file, then you can open it as a browser in your browser. So that's how we communicate with the server. So actually, if you type the website here, what's the website? Vision. So you can try to type http vision.ucla.edu. You can also type the port number, but because we have already specified HTTP, so you don't need to do this because the default port number for HTTP is 80. So as you can see here, we visit this website. That's the content. And because we have a error here, so let's run it again. What's the command again? Is get. We are get the main page with the HTTP 1.1 version, and the host is vision.ucla.edu. So we just run it, and okay, so this is the web page content we have received from the server side. As you can see, it's pretty long, and this part is the header of the response. So it's a bit different, right? Comparing to what we see in the browser. But if you can press F12, then you can open the debugger for Chrome. And you can refresh this page. Then you can see the response header is in here. Should be the same as we see in here. It's quite similar, right? And the web page content is in here. So let's just have a quick look of the response in here. So you can see it's the same one. You can do the comparison by yourself. So that's how we communicate with the web server. So once we type the URL in our browser, so actually we are sending this kind of stuff to the server, and we have received this kind of HTML file as response. But the Chrome browser can help us to translate the web page into this kind of visual content so we can easily understand it. So you can play around with the debugger in Chrome. So that's the telnet. So follow the steps and do all the tasks. It can help you to understand the HTTP. And this is the exercise 1. And the exercise 2, understanding internet cookies. So when we trying to visit this web page, google.com, then you can press F12 and refresh. You can see we can have a look of the header. It contains a lot of headers in the response part, and one of them is the cookies, set cookie. Do you mean what's the meaning of this? Like, or you can press the cookies tab here and see what is the cookies here. There are lots of content inside, but we cannot easily understand it, right? The value is strange. Usually we cannot read it. Do you have any idea, like, why should we have this kind of header, this kind of cookies? So there are maybe 2 or 3 main reasons. Can you name one of it? Any idea? Why should we have the cookies? Yes, persistence is one of the reasons. So sometimes we need to log into Google, right? Sometimes like we want to log into our account, but the Google server cannot remember everyone by using our IP. So it must have a method to like specify which user is this from this request. So the cookies can help the server identify which user is this. So this is one of the reason. But now I didn't log in, but I still using the cookies. As you can see here, we have an NID. So this one will help the server, like Google server specify which machine is this. So even I didn't log in, I still have my data in the Google server. So the Google will know which website or which term have I searched. So this is very important for their advertisement service. So if I search for the like comics, and maybe in the advertisement, it will present some comics related advertisement to me. So that's one of the reasons. So they call it customer tracking. And we still have lots of reasons for using cookies. But as you know, the cookies is not very like say not very safe for us to use, especially when we expose our cookies to others. So maybe someone can just copy my cookies and then they are just using the same cookies so they can pretending they are the same person. Like if I log into my Google account, log into my Gmail account, and you saw my cookies, then you have the chance to just use the same cookie and then log into my Gmail account. But now they have updated their like security algorithm. So use these same cookie will not work. It will combine like the IP address or other methods to do the verification. But you still need to protect your own cookies. Okay, so next one. You can do the question to answer it by yourself. So just open the F12 debugger, then you can see all the details about it. And from exercise 3, we need to put it into our report. So I have already write some notes for this one. Let me check. So you can access this web page by click the website here. So in here, you can see the further information link here. So you just click the link, then you will jump to the notes. I already put some quick notes for the exercise 3. 4, and 5. So you can have a look later. Okay, let's do the exercise 3. So the first step, we need to download the file. So just simply download it and open it. Double click, then you can open the Wireshark with the trace file. As you can see here, the trace file is a sequence of the packets, including all the communication from our machine to the outside. So you can see the IP address is different, the sender and receiver, because we only care about the HTTP packets. So we need to apply a filter. So just simply type HTTP, then you can see only 4 packets. So let's just read it one by one. So what's the first one? Is from this IP address to another one. So usually you see this kind of address is from your uh, own internet, like your local internet, 192.168. You can double check of your IP address. Usually it's this one. So we are always using this kind of IP address to communicate with our routers. And then the routers will send the packets to our destination, which is the public IP address. Okay, so the first packet, the protocol, I don't need to say that because all the packets is in HTTP, and the length, the critical information is in here. As you can see here, that's what have we learned last week. This one is definitely a request for HTTP because we can see the header of it. If you want to see more information, you can click the tab here to see all the headers in the request. So you can see this is the first row of the header, second row, third row, and etc. So try to understand it. If you don't remember what is this, like what is get, or what is the following like HTML contents, and what is 1.1, then you need to go back to your lecture slides. Or if we have time, we can have a look of it later. Just let me know if you have any doubts. But in here, all the contents is in here. You just need to go through them one by one, then you can answer the question. Let me check what's the question we have. Okay, so just follow the steps and answer the questions. What is the status code, right? So how can we figure out what is the status code? The status code is always in the response. So we have 2 response here from the server. You can figure this out by have a look of the IP address or have a look of the header of it, because we have know the request is always getting started by the method, and the response is always getting started with the HTTP version with the status code, right? So you can see there are 2 status code, 200 and 404 here. So you need to figure out which one is the packet we are talking about. So let me explain why do we have 2 different requests and response. So when you visit a website, let's say WebCMS. So you just press F12 And then let's refresh, and we change to networks here. So we can see the communication between our own computer to the server. So let's just refresh again. Where is the website? It's here. So this is, sorry, this is the header of the request. We send a GET request to get this website, right? And then we have the response for the whole content for this web page. And what else do we have? As you can see here, we send a lot of requests and receive lots of response, right? So what else do we have? The FAV icon. What is this? We have already seen it in the Wireshark, right? FAV icon.ico. We are trying to get in this one. So let's see, what do what did we receive here? We are trying to get the FAV icon in here as well. Even we just want to visit this website, why did we send lots of requests? Any idea? Like, why should we send lots of requests and receive lots of response here? Even we only want to visit one website. And what is the FAV icon.ico? And you can see this is the response. And this is the preview. You can preview them. You can see this one is the web page, the content, and this is JavaScript, and this is my icon, and this is the picture of in here, and another JavaScript, and empty file, empty, and the result, some kind of data here. And what is this? What is the ICO file? Can you see where is the images? Yes, exactly. So have a look over here. The ship is in here, the icon of the web page. So sometimes, for example, this web page, we can refresh it. As you can see here, it doesn't have the icon, right? So it will not show the icon here, but uh, sorry, I didn't see we request for it. Maybe HTTPS. Okay, they don't have the HTTPS. But anyway, now you got the idea. So once we receive the HTML from the server, we will also request for all the images and other content that is not included in this HTML file. So we need to send the request one by one to get all the elements in here, including my icon and the icon of the web page. So now you can understand why should we have two requests here. So the first one, we want to visit this web page, then we receive the response for it. Then we send another request to get the icon of this web page, and the server says, no, we don't have any icon. So that's the whole conversation. So you need to focus on these two because these two are the request for the icon. So we don't care a lot about it. So we only care these two. When you try to when you're trying to answer the question, please just have a look of these two stuff. The first one is the request. The second one is the response. Okay, so I think that's it for this one. I think question 3 you may have some question about like how can we figure out if this is the persistent connection or not. All you need to do is in the HTTP tab, you just figure out by reading the headers here, reading this one, try to figure out what is connection keep it alive and how many bytes is you can have a look of the length of it, or you can also have a look of the header of this one. And what is the data contained inside the HTTP response packet? So you need to figure out which one is the response you are looking for. There are two responses in here. For example, I have a look of this one. How can I see the data inside? The first one, you can have a look of the content in here. It's in binary, right? It will translate the binary contents into the text. And you can also find it at the end of the tab. So this is the content you are looking for. So that's how we answer the question. Okay, so exercise 4 is very easy for you. Let's do the uh let's do the exercise 4 right now. We download a new one, another trace file. Trace file. Okay, so a sequence of packets. We only care about the HTTP, so we apply the filter first, and then have a look. What kind of conversation do we have here? The first one is a get, it's a request. Second one is a response, 200 OK, which means we got the response. And the third one is another get command for the same URL, right? And the fourth one is the response for the third. And it says not modified, as you can see here. Even we request for the same web page, we could have different response, and we are going to figure out how could this happen. Okay, so let's have a look of the question here. Did you see this header? So you need to have a look of the get and then go to the HTTP area and have a check for the headers here. Have a look of them by yourself. And then the question 2, does the indicate the last time that the request was modified? So you need to have a check the header as well. We are looking for the response at this time. Did you see any related content? The E tag and the last modified content. So you need to pay attention to these two. I put the explanation in the GitHub link here. In this part, what is E tag and what is last modified. So both of them are using to identify a specific resource. So just imagine the E tag is the ID number for the file. And the modify things, you can imagine this one is the date of birth of the file, of the response. So why should we have these two stuff in the response? Why do we need to have the ID number and the date of birth of the file? If you have a look of the length for these two response, then you may have some clue. So try to answer this one. So why should we use this tool? If you look at the length, then you may have some clue why should we need to do this. Comparing the first response and the second response, you can see the size is like totally different. We significantly reduce the traffic. And I want you to figure the question 3 and 4 by yourself. Should be pretty easy for you. Just have a look of the header, but you need to figure out which packet are you looking for. And when we comes to the E tag, then you want to comparing the E tag in different packets across different packets. So have a look of the if not match header and the E tag header and the E tag header here. So across these 3 packets, did you see any difference between the E tag and like how they use the E tag in the conversation? Try to figure this out and then put it into your report. But I have mentioned this before. The E tag is basically the ID number of the response, and they are using it for saving the traffic. As you can see here, the length is totally different. So do your investigation and answer the questions. Okay, so we come to the exercise 5. Have anyone like already finished the exercise 5 or already tried to do it? And I have a poll for this one because we are going to do some programming stuff. So I want to know like which language are you using? Like for this course, I know like most of you may know different languages, but for this course, which languages are you plan to use to do the assignment? Okay, let's wait for 1 or 2 minutes because I need to know which language are you using, and then we decide which language are we going to explain. The idea is pretty simple. All the logic are the same, but in here I recommend you to use Python because Python have very easy syntax and the library is very easy to use as well. But if you are using C, you may spend a lot of time for doing the same job, but like depends. Sometimes some students are pretty good at C or Java. Okay, that's great. We have like everyone are using Python 3, so are going to explain the exercise 5 in Python. Let's have a check. The first thing you want to do is to go through all the contents for the exercise 5, but just in case you don't have time, I give you like 2 minutes to read it. Just have a look of the best, uh, the maybe the first paragraph. Just try to figure out what are we doing right now. Oh, I'm sorry. I think I missed something because I closed my microphone. So let's get started from the beginning from for the exercise 5. I'm sorry about this. This is the client and this is the server, and we are going to write something like this, right? This is an example of this. And so we are going to download and compiling and run the server first. To download and run the server, we need to just follow the steps, like download the file first and then run the command to compile it. And you will have no output, but you can have a double check by running the ls command. Then you can see we have a class file for the Java. Then we can copy the command to run it in here. And you need to replace the port by a port number. And we are running it in this port number 6666. Then you can see we are running it, but we have no output because we are going to write a client that can communicate with the ping server. And I have already done the server as you see before in here. I run it with the Python 3 command, attaching with the file name, and this is the IP address of the server, and this is the port number of the server. After I type the enter, then you can see they are communicating with each other like this. So, do you have any idea how to write it, or did anyone try to implement this? And if you have any question, feel free to post it. So I know like which problem are we focusing on. Otherwise, we will just start from zero, just in case you have no idea how to do it. Because I know most of us have no idea what is socket and how to do this. Yeah, how to check the IP address of the server. So for the server we are running for the program is always our local host, which is the 127.0.0.1. And we are going to specify in this file, actually, you can have a look of the ping server.java. You can have a look of the source code of it. It will specify the port number and the IP address as somewhere like request go address. So in here, I didn't see any IP address specified. So we are using the local host. Yeah, I think we are using the local host to run the socket. Yeah, but sometimes, like for example, in the future, you are doing your own application for the UDP or TCP connection, then you may use your, like, let's say public IP address. Then how can you get your IP address? Do you have any idea? There are lots of ways to do this. The most easiest way is just running the web page, right? You just open the Chrome browser and type IP address. What is my IP address? Then you can see this is my IP address in public. But you need to be aware of this. You are using this IP address with lots of people because this one is the VLab in UNSW. And we are sharing the same routers with lots of people, and they are all using the same IP address. So this IP address, you need to have the access of the port number, because once we send the packets to our router will like mapping our IP address, our like in the LAN IP address into the public IP address with another port number. Don't worry about this part because you will learn it very soon. But we call it like port mapping in IPv4. This will be learned in week 6, I guess, or no, week 7 or week 8. But don't worry too much about this. It's a little bit complicated to explain by now. But when you try to do the public IP address for the communication, make sure you have the port number like accessible, and you should know what is the port number in the public IP address. When you try to do the communication while the IPv4 address, then you have to have the access to your router. But in the VLab environment, we cannot do this because we cannot control the router in UNSW. So we cannot communicate with outside easily. And that's the reason why we are using the localhost 127.0.0.1. When you do the assignment and the lab, always use this IP address to do the test. And you don't need to worry about the IP address. We only worry about the port number here. And the port number we have already specified when we run the server in here, right? So we just run it. And in the client side, we specify the IP address plus this port number in the server. Then we can run the program. See, that's the program we want to write. And let's try to figure this out, how to write a simple client that can communicate with the server. So I just open the spider here. Okay. Where is my spider? Cannot find it. It's already running, but I cannot see it. Let me try to rerun it. Okay, it's here. Then, okay, this is the spider. We create new file, and we are going to send some packet to the ping server, right? The first thing we want to do with the spider is to import the socket library. And we can write a socket program. So the first thing we want to do is to initialize a socket object. So we call it socket equal to the socket. Don't worry about this part. You can easily find the like reference online, like by how to write a UDP socket, UDP client. You can easily find some information about it. And family equal to inet, and the type equal to socket dot dgrm diagram, which means the UDP socket. So this stuff is how can we initialize a UDP socket. UDP socket. Then the second step is to send the packet to server. It's pretty easy. Once we initialize the socket, then we can use the socket to run the send to command data, right? Then we need to specify what is the message we want to send. And we need to send the message with the encode command. We are using the UTF-8 for our encoding. So the encode method for the string will translate the string into a byte. And then we need to specify what is the IP address of the destination, which is the server IP address. And then this is the port number, right? And this is the program for the client, and we are going to run it right now and see how it goes. Let's try to run this one. Have no, oh, sorry, I made a mistake. The diagram, DGRAM. Yeah, don't worry about how to initialize it, but there are lots of information online that you can search for. Just memorize this one, and you can see we sent a message to the server side. Let's try to modify the message and send it again. You can see we have already sent it. And the next step is to receive the response from server. How can we do this? It's also pretty easy. Just run another command, right? Any idea? Like sock dot. If you have no idea, you can go through all the methods in here. Also, you can type receive from, right? Just and put a number here. Usually we put 1024 as our buffer size. And we can see receive data equal to this one. And then If we have received data, then we just print it. Yeah, yeah. Okay, so that's the program. First step is to initialize a socket. Second step is to send a packet to the server because the server will reply another message to us, right? So we want to print the received message from the server and see how it goes. Let's try to run it again. You can see we print a lot of stuff here. As you can see here, the response contains two parts. The first part is the payload of the message, including all these symbols. And the second part is the IP address and the port number of the server. So when we receive the data, we can divide it by two stuff, right? The first stuff is the received message, and the second step is the received address. Then we can print it out. And this is the received message, and we need to decode it. You can put it UTF-8 or not, because the default decoder is UTF-8. And let's try running again. You can see it make more sense. Get response from this IP address, which is our server, and it says hi world, right? Just like the same. So this is the program, and we try to run it for twice. As you can see here, reply not sent, and then we are stuck here. There is no response. Then we are running here, waiting for the response indefinitely. So how can we do to like figure out we have timeout? We just need to add one more line into the code in here. The socket set timeout, and we put 1 second as our timeout, which means if we didn't get a response in 1 second, then we will raise an error and break the program. Let's see how it goes. Run it. Okay, reply not sent. You can see we will have an error for timeout. So that's how we figure out like if we time out or not. So this library is not very easy to understand at first, but as you can see, it's pretty easy to use, isn't it? And here we only used 23 lines to explain 3 different functions. If you have any idea how to do the program right now, I think this should be enough for you to getting started. You just need to have like put more logic into the program, then you can get it done. And another stuff for this is the web page. I have already shown you before. In the labs, and after the recording link, you can find the further information for the GitHub link. At the end of it, I have already uploaded a 5 minutes video just in case you don't have enough time to review the recording for this. So you can go to this, sorry for the advertisement. You will be able to have a look how to do the lab2 question 5 within 5 minutes. Let me show you. I also put some codes inside, but I'm not going to share this code to you because I want you to type the code manually. So you can like take a screenshot if you want, but I want you to type all the code by yourself. And in this video, I have explained like how to do all the stuff, how to send the message, and then how to use the try and accept command to catch the exception and etc. I think this should be enough for you to get it done. And we have 2 more extra tasks. Where is it? Yeah, we have 2 more tasks. If you still have time to do it, try to do this too, because these two will be very useful for your assignment, especially the second one. This one is definitely be used in your assignment. I would say like it's the major part of the assignment, but this one is quite difficult to implement it. But like if you don't have time, don't worry too much for the this extra part because you should not be included in your report. But you are welcome to do the submission, including these 2 parts, so I can have a look. If you like, for example, you done this part, like send a packet per second, then it should be looks like to my program. Like we send a packet per second. You can see at the left hand side, 1 packet per second instead of sending all like in 2 seconds. But don't worry too much about this part. Just try to get the exercise file at first. And for the assignment, you don't need to worry about it for now, at least for week 3 and week 4. Because if you have no idea how to do the socket programming, it will be a little bit hard. But after this week and next week, we are going to do more programming stuff like this. So you will like gradually understand how this one works, how to send a packet and how to receive a packet like this, and how to manipulate all this data inside and how to use the socket to send or receive any stuff. And in week 5, we are going to have a tutorial for the assignment. And I will, maybe me or another tutor will explain how to like getting started with your assignment from 0. Okay, so I think that's it for the assignment, and we still have 15 minutes. Feel free to do the assignment right now, especially for this part. So if you have any question, just send it to me, and you can also share your screen. And I will stop the recording right now, so you can share your screen.